I'm Anil Kumar. Welcome to my series on solving linear systems by substitution. Now here is part B. In part A we did question number 1 to 5 all with substitution. Now in part B we'll add both the methods. We'll do substitution as well as elimination, right? I hope you enjoyed the break. Now let us see how do we solve questions by both substitution and elimination. Question number 6 is the sum of the squares of two numbers is 35, 38 and the difference of their squares is 20, 80. Determine all possible values of the numbers. So we'll begin with the let statement. Let the numbers be A and B. I have used capital letters for defining my variables. You could use lowercase also. When it says sum of squares of two numbers is 35, 38, it means A square plus B square is 35, 38 and difference of squares is 20, 80. So A square minus B square, that is the difference, is 20, 80, right? So that is how you get two equations, two variables to figure out. We'll call these equations as equation 1 and 2. Now we'll actually solve the complete question using both the methods. Let me do elimination first. Elimination is simpler here. In elimination, as you can see, if I add equation 1 and 2, what do I get? If I add them, b square will cancel out and we get 2 times a square, which will be equal to, adding these two, we get 8. 8 plus 3 is 11, 1, 6, 3 plus 2 is 5, correct? Now we can say a square is 5618 divided by 2, which is, dividing this we get 2, 8, 0, 9 is a square. So the value of a will be plus minus square root. So whenever you do square root, you have to take both positive and negative values, right? So those are the numbers which we are looking for, square root of 2809, and that gives you 53 as your answer. So we get a as plus minus 53. Is that clear to you, right? So you get two values, plus or minus 53. Now, just to give you an idea how to use substitution method here, so we'll do method 2 for the second variable. So method 2 is by substitution. This is just to illustrate, okay? You have to follow only one method to when you solve, right? So we can actually isolate one of the variables from equation 2. I could write from equation 2 that a square is equal to 2080 plus b square, right? So we'll call this as our equation number 3. Now we'll sub equation number 3 in our equation number 1. So a square is 2080 plus b square, which I'm going to write here. So we get 2080 plus b square. We already have b square here, equals to 35, 38. Now that gives you 2b square equals to 35, 38, take away 2080. Or 2b square is equal to, so when you take away, let's use calculator, we'll have to divide by 2 and then square root also. So we'll do 35, 38 minus 2080 equals to 1458. So b square will be 1458 divided by 2, which is 7, let's write here, 729. And b should be equal to plus minus square root of 729. So if I do square root of 729, I get 27. Do you see that? So we get plus minus 27 as our answer, right? So the two numbers could be, for A, could be plus minus 53, right? And for B, it will be plus minus 27. So we have our answer here, and that is A equals to plus minus 53 and B equals to plus minus 27. So that is how you could do it. Now it's very clear you could follow any one method and solve, right? So sometimes elimination is better. However, we'll solve all the questions with substitution but show you elimination on the side, just as we did here. Is that clear to you? Okay, let's take the next question, which is question number 7. It says the denominators of two fractions are 4 and 5. The sum of the fraction is 43 over 20, but it is 19 over 10 if the numerators are switched. Determine the numerators, right? So here, when you define the variables, we'll say let the numerators be A and B, right? So in that case, we know the denominators are 4 and 5. So then we said the denominators of two fractions 4 and 5. So we have the fractions are A over 4 and B over 5 are two fractions. Clear? Now we can write the equation. The statement here is the sum of the fraction is 4320. That is to say, A over 4 plus B over 5 is equal to 4320. But it is 1910 if the numerators are switched. That means if we switch them, we bring B here, right? And A on the other side. If we swap them, we get 19 over 10. So that gives us two equations. Is that clear? Right? Now, whenever you have fractions, it is a good policy to get rid of fractions, right? So the concept here is get rid of fractions. So in this case, denominators, right? How? We can multiply by the common denominator, right? So in the first equation, if I multiply the whole equation by 20, what do I get? And the second one, I'm going to multiply by 10 and see what do we get, right? So multiplying by 20 gives me, you kind of cross multiply, you get 5a plus 4b equals to 43, right? And here you get 5b plus 4a equals to, so when you multiply in this case by 20, I should multiply by 20 this one also. So we get 2 times 19, right? 2 times 19 will be 38. Is that clear to you? So that is what we get. Now if you look into this, isolating A or B will again lead to fractions, correct? Right? So how could we go about? Now we could write, because we need, let's say, B, we need 5B here. Okay, so let's isolate what B is from this place. So we have 4B equals to 43 minus 5A, and then we can divide by 5. Is that clear? We could do that. So substitution is kind of complicated. In this case, elimination method is much simpler. You could multiply the first equation by 4, second by 5, and then eliminate. That was simpler. But let's continue with substitution method since this is more difficult. Okay. So what we will do here is basically isolate one of the variables. So we can write this as 4b equals to 43 minus 5a, right? 4b is this. So that means b is equal to 43 over 4 minus 5 over 4a. Clear? So we get b. We'll substitute this value of b in the second equation to solve for A, right? So when I substitute B here, we get 5 times the B value is 43 over 4 minus 5 over 4A, right? Plus 4A equals to 38. Is that clear to you? So that's what we get. Now we need to simplify this. So since we have this denominator of 4, we can actually multiply everything by 4 and then rewrite our equation, right? So if I multiply by 4 everything, I get 5 times, here we get 43 minus 5a, right? Plus 4 times 4 is 16a equals to 38 times 4. 4 times 8 is 32, 2, 3. 4 times 3 is 12 and 3 is 15, right? So we get 152. So let's use calculator. We have 38 times 4 equals to 152. Now we will multiply these numbers, isolate A and solve for it. Okay, so 43 times 5 equals to 215. So we get 215 minus 25a plus 16a equals to 152. Okay, so let's take it on this side to solve for a. So we have 215 minus 152 equals to 25a minus 16a, correct? So we took these a values on the right side, and now 215 minus 152 equals to 63, and 25 minus 16 is 9. Dividing 63 by 9, we get the value of a as 7, correct? So we get the value of a as 7. Now we can substitute this value of a as 7 and find what b is, correct? So the value of a will now be substituted to find the value of b. So b is equals to 43 over 4 minus 5 times 7 over 4, correct? So we get what? 43 minus 35. So we get 43 minus 35, which is 8. We get 8 over 4. So we get a value of b, which is equal to 2, right? So b is 2 for us. So it was slightly complicated. However, we finally really got the answer, as a equals to determine the numerator. So the numerators are a is 7 for us and b is 2 for us, correct? So that becomes the answer. And the two fractions, as you can now see, is 7 over 4 and b is 2 over 5, okay? You can verify that when you add them, you'll get 43, 35 plus 8, and when you swap and then add, you get 19 over 10. So that makes sense. Clear? So that is how you could do with substitution method. Perfect. Now, I would like you to try with elimination. So when you are trying with elimination, you could multiply this equation by 4, the other one by 5, and then subtract to get your answers. That will be much simpler. I hope that makes sense. Let's move on and take question number 8 now. Question number 8. Anil has 5% and 10% solution of hydrochloric acid. How much of each should be mixed to make 250 milliliter of 8% hydrochloric acid? Now, whenever we have mixture problems, I will like you to look into this particular format. So we are mixing two things, which I am showing with the help of a diagram, getting the third thing, right? So the whole idea here is to mix what is available to get what you need, right? Now, we have 5% and 10% solutions. So I'll write this as 5% and this as 10%. Now, when I say 5%, it really means what? It means in decimals 0.05, clear? 10% means 0.10. So that is the decimal equivalent. So it's a good idea to write percent as decimal value, right? So that is one part. The second part here is look into the quantities. Well, let me complete this. 8% will means 0.08, right? In decimals, that is 8%. Okay. Now let's look into the quantities. We need 250 milliliters, right? So of 8%. So this is 250. Now, how much quantity of each will give us 250? Let's say X and Y is the quantity, correct? Of the two. So clearly from here we get one equation which is X plus Y equals to 250, and we can eliminate one of the variables saying X equals to 250 minus Y, clear? So we get our two equations from one of the conditions, that is the total is 250. Now let's look into the concentration part of it, right? So when we say X milliliters of 5% hydrochloric is added with Y milliliters of 10%, we get the equation as 0.05, which is the percentage, and X the amount, add them up, to 0.10 of Y to get 250 milliliters of 8%. That means 0.08 of 250. Does it make sense to you? So we get our third equation using the percent solutions, correct? Now we can substitute 2 in 3, eliminating X from the second equation. X is 250 minus Y, so we could write this as 0.05 times 250 minus Y plus 0.10 Y equals to 0.08 of 250. Clear? Let's open the bracket. We'll use calculator again. So 0.05 times 250 equals to 25 by 2, which is 12.5, minus 0.05y plus 0.10y equals to 0.08 times 250. That is 20. Clear? Now we can combine the y terms and the constant. So we get 0.10y minus 0.05y equals to 20 minus 12.5. Correct? So that is 0.05y, and this is equal to 7.5. Correct? So we can now divide 7.5 by 0.05 to get 150 as y value. Is that clear to you, right? So we get y equals to 150. So we get y as 150. Let me call this as equation 4. Substituting 4 in 2, we can get the value of x, right? So x is equal to 250 minus 150, which gives you 100. So we can now write the answer, which is, we want to find how much should be mixed, right? So x for us is 100 and x is 5%, right? So we have 100 milliliter of 5% and we have 150 milliliters of 10% hydrochloric acid, right? In short, HCl. So that is how it can be solved. Now, as you can see here, this small diagram helps you to understand how to write equations, visualize the situation, and solve the problem. Perfect. Let's take up the next question now. Question number 9. Peter rows 9 kilometers downstream in 2 hours and 8 kilometers upstream in 4 hours. Determine his average rowing speed and the speed of the current. So this is a very popular question. Let's say that is the river which is flowing in this direction. So we are given that going down by 10 kilometers, let's say up to here, it takes 2 hours, right, which is 10 kilometers. On the other hand, moving up to only a part of it, which is, let us say, 8 kilometers, it takes 4 hours. So that is the situation given to us. Now, why is it so? It is so because the average speed is same. So we can write here, let average rowing speed be, let's say, R, and speed of the current, and current be C, right? So let's say these are the two variables. Now, whenever we have distance time questions, right? Whenever we have distance, speed, and time questions, you have to look into this particular triangle, which we discussed earlier also. So we have distance is speed into time, right? So distance is speed times time. It is always good to write equation in terms of product so that you avoid fractions, correct? Now, I will suggest to make a table here. So we'll make a table in which we'll have 3 columns, one for distance, one for speed, and one for time. Okay, so we say distance. Distance is given to us in kilometers. Speed is given to us in kilometers per hour. And time t will be in hours, correct? Now we have two conditions, one going down, the other one is going upwards, right? So we will have these two conditions here. So we say down and up. Okay. So distance traveled downwards is 10 kilometers. What is the speed? When you are going down, in that case the rowing and water current both are in the same direction, so the speeds add up. So we have this speed as R plus C. Time taken is 2 hours, so it is 2. While going up, we have a distance of 8, but the rowing speed minus current is the net speed because current is against, right? And therefore, it takes much longer, it takes 4 hours. So that is how we get all the values. Now from these values, we can easily get our equation, right? See how. Distance is speed into time, right? So distance is speed into time. That helps us to give us the equation. Perfect. Now, here the values are such that even if I divide 10 by 2 and 8 by 4, we do not get fractions, right? So we could also use the relation speed is equals to distance over time. That will be simpler for us. Correct? So now we will see what R plus C is. So we know speed S is distance over time. We are using this equation mainly because 10, 2, 8 and 4, they are factors, right? So we don't really get any fractions, correct? So let's write our equations. First one, R plus C is the speed, right? So we can get from here R plus C is equal to 10 over 2, right? Which is 5. From the second equation, we get R minus C equals to distance of 8 over 4, which is 2. Do you see that part? So we get very simple equations to work with, right? So basically our equations are R plus C equals to 5 and R minus C equals to 2. If you are solving with elimination, Then you can add these two, eliminate C, get value of R. Simple as that. But we are going to use substitution in our case now, right? Since the whole exercise is to focus on how to use substitution to solve the equations. Now from this equation, you could isolate one of the variables. So from here, I can write R is equals to C plus 2, right? Or 2 plus C, right? So let's call these as our equation number 1, 2, and 3. So we'll now sub 3 in equation 1. So we get R as 2 plus C equals to 5, or 2C equals to 5 minus 2, which is 3. So C is 3 over 2, right? C is 3 over 2. You could write this as 1.5 also. And what is R equals to? R is equal to 2 plus C, which is 2 plus 1.5. That gives you 3.5. Is it okay? So you get R as 3.5. Determine average rowing speed and speed of the current. We get our answer. Rowing speed is 3.5 kilometers per hour, and water current is 1.5 kilometers per hour. Is that clear to you? So that is how this question can be solved, right? So I hope that helps. This table is very versatile. It can always help you to solve any distance, speed, and time question. Perfect. Now let's take the last problem of our series, solving equations by substitution. Question number 10. This is based on investments, and we'll actually understand a strategy to solve all such questions. The question here is, Sam invested $2,700, a part at 8% per annum and the rest at 10% per annum. In 1 year, the total parts earned equal amounts of interest. How much did he invest at each rate? So this is kind of reverse of mixture. We have something here which we want to invest in two places, right? So the diagram is very similar, right? However, the difference is that we are now splitting the amount which we have rather than adding two things which we had, which we did in mixtures, right? So that becomes our diagram, right? Sam invested $2,700. So we have $2,700 with us, and these two are the investments which we are looking into. So here there's one investment of 8% and the other one 10%. So 8% and this is 10%. Is it okay? 8% we'll write 0.08 and 10% 0.10. Clear? Okay. We are actually interested in finding out the amounts X and Y which are invested in these. Right. So total is 2,700. So clearly X plus Y should be 2,700. So we get X plus Y equals to 2,700. So we can now write what X is. It could be 2,700 minus Y. So we get these two equations. We'll call them our equation number 1 and 2. The second equation, rather the third equation which we get, is based on the condition given to us. In 1 year, the two parts earn equal amount of interest. So what is interest? Interest is basically equals to PRT, principal rate of interest, and time, right? In our case, T is equal to 1 year, since in 1 year T is 1, right? So principal amount is this X in the first case, and rate is 8%. Do you see that? So that is what is there, right? So interest in first case is equal to the amount X times 0.08, right, times X. And interest in the second case will be 10% on Y, right? So 0.10 on Y. We are given that I1 and I2 are equal. correct? So that is what is given to us. So we can equate this and we can say 0.08x equals to 0.10y. Clear? So that should help us to solve this particular question, right? Now, since we know x is 2700 minus y, we can eliminate x by substituting the value, right? So we'll see this as our equation number 3. Substituting 2700 minus y for x, we get 0.08 times 2700 minus y equals to 0.10y. Now we have equation in one variable which we can solve. So let's do it on this side. We'll use again the calculator. So we have 0.08 times 2700, which gives us 216. So we get 216 minus 0.08y equals to 0.10y. Correct? So let's take it on the right side. We get 216 equals to 0.10y plus 0.08y. 216 equals to 0.18y, or 216 divided by 0.18 is the value of y. So we'll divide this 216 by 0.18. That gives you 1200. So y equals to 1200. Clear? So once we get the value of y, we'll call this as our equation number 4. Now we'll sub 4 in equation 2 to get the value of x, which is 2700 minus 1200. Is it okay? So we get this value as 500. So our answer here is that $500 is invested at the rate of x is 8%, right? And $1,200 were invested at 10%. Does it make sense to you? So that is how we could solve it. So I hope with this you understand very clearly how to solve a linear system using the method of substitution. In many cases, you could use the method of elimination also, but we'll take up elimination method in a separate video. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.